Our basic task today is that how to convert an analog into digital. What are the methods? What are the steps of converting an analog information into the digital information? For that purpose, let me share with you an analog signal and then how that analog signal is converted into digital signal. What are the methods? What is the technique to do so? I'm sharing this figure exactly from your book. This example is there in your book as well. And we can use the different examples for this purpose as well. So when the signal is plotted, this is the blue line is your signal and it is plotted time on the horizontal axis and voltage on the vertical axis. So the value of the voltage at 0 time is 9 volt and then it becomes 10 at 100 microsecond. Then 200 microsecond, the value is different. So you can read the values at different intervals. These intervals are important for us. Where we want to take the readings, that is really important for us. Okay. So where we take the readings, that is called the time interval, and the smaller the interval is, are you right? Smaller the interval is, the better digital we get. The better digital we get. So in place of sampling it at 100 microsecond, every 100 microsecond, if we sample it at every 50 microsecond, it would be more better. Okay. Then definitely on the vertical side, we are just going till 10. Why to go till 10? If you can further divide it, it's not, this is 1 over here. So better it's 10 over here. So this is not 10, this is then 100. What it would be to write the 100, definitely we have to go to more bits. We have to increase the bits in the data. So more bits in the data, the better the digital you will get. Number one is sampling rate. We need to reduce the sampling rate, not to increase the sampling rate. Reduce the sampling size basically. Reduce the sampling size, increase the number of samples. Increase the number of samples. If you sample after every 100, so it's a very larger time that you are sampling. Okay. The first sample I take is at 9, at 0. And I take the sample as, this is my 9, and you know 9 is written as 1001 as according to 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3. To write 9, this is definitely 8, and this is 1, 9, another 2s are 0. So this gives you the 9. This is your first. After that, the next at 100 level, you just go and read this is 10 and you get the information in the digital form. Then after next 200, you again get the information. It's again the same. Okay. Then you get at 300 and this information is in between. You don't take it. You haven't taken any value over here because of the problem. What is the problem? That from 8 to 9, you do not have any bit system that you can include it. If it would have been 80 and it would have been 90, then definitely it would be 81, 82 or 83. So you can get the digit 83 exactly. So that would have improved your accuracy of converting analog into digital. You finally took the value over here at 400 and the value is noted as this, which is 8. And then this value you haven't taken again. And again, this 600, you haven't taken any value. And at this value, which is approximately 700 you have taken again this value. So 800 you are taking this value again, and then this is at your 900 and this is at your 1000. So you have got the digitals out of the analog. What you have got? You have got the digital information out of analog information. There was just a graph, but putting the values of the time over here and putting the values of the voltage over here, we were capable of getting the values at different steps. So we have got the digital one. So use of the binary, which we have just studied, use of the binary information, 2 raised power 0, 1, 2, 3 system, and the number of the steps we have get it on the x-axis, we were able to get the information in the form of this over here. Okay, beta. So this is what we convert analog to digital. Okay. So once the analog to digital is converted, so our sampling is definitely an issue, and that we have to get a better if we sample at little more smaller time interval, and we have more samples are taken, that automatically improves the accuracy of your digital. Then finally, we have to convert this digital into analog signal. This digital into analog signal. How? That I have now collected this information which was with me. What was that information I have got from this table? These are the values which I have got. This is your first value. This is your second value. This is your third value, if I'm not wrong. Oh, sorry. This is again your first, second. This is third again. This is your fourth value. This is your after fourth. Again, this is the same value. Then we have the fourth, six values again. This, okay. You can number them. You can note them in a table that which value is at which number. Let me invite Maz again. Sorry, beta. Oh, he's in again. So what we do, we can just make a table, and into the table, according to the numbers of the samples, that the first sample, the second sample, the third sample, the fourth sample, the fifth sample, the sixth sample, the first sample which we have taken, that was 1001. Then the second sample which we have got, that was 1010. And the third sample which we have got, again, that was 1001. So fourth sample which we have got after that, that is the values which are over here, that is 1000. Okay. Then there was the fifth value which we have, fifth sample which we have got, that is again 100. And then there is a sixth which we have got again, that is again 1000. Then there is a seventh as well. And what's the seventh sample which we have got as 0111. And then finally the eighth sample is also there. And what is the eighth sample? That is 0011. This is the sample number 8. Now, according to the number of these samples, we can now plot it again, and we can convert this into the equivalent analog signal as well. Okay. Again, getting the help from the table. I have got it over here. Time definitely the same. What I have just plotted these little steps of the digital one. Second step was this, and these steps are exactly of 100 intervals. 100 intervals. These steps are of 100 intervals. Okay, and these steps are representing, because here were the two values, exactly the similar values, so we prolonged it. Here all the values were, so this is the last one, the 80011. This was the second loss, 0111. Similarly, this is 100, and this value is over here. So we have plotted all the values. Then what to do? Starting from the first point and taking the middle of every, we draw these dots and we join these dots. This is your analog signal. So this is the way we have gone from digital to analog. So once we are capable of converting analog into digital and digital into analog, so we have got the basic technique of sampling and basic technique of converting the information into digital and analog forms.